tutorial, we will demonstrate how to use Web VPython to create objects. So when you go to glowscript.org website, you will see the link for the Web VPython and a Trinket tutorial created for learners in introductory physics. So if you go to help, you can see the documentations related to the use of Web VPython. So Web VPython is a browser-based application for modeling 3D animations. So we go back to the Web VPython. There are also existing examples of programs that you can try. So we have atomic solid models, binary stars, and so on. So if you click one of these, let's say we run binary star program, you can see the motion of two interacting objects. So what is interesting about a Visual Python or VPython is that you can manipulate or see the 3D image or the 3D model by just using your mouse. So use right click and then hold right click, and then you can move the 3D model or 3D object. So if you click view this program, you can see the whole script or code developed to create this model. So if you again run this program, you can see that the motion can be played. So we go back to the other samples. So instead of starting from scratch, you can also modify the existing models or scripts that we see in the examples. So here we have a double pendulum. And by clicking the view this program, again, you can see the sample script, which is used to model this motion. So these are read-only programs, but if you use your email to sign in, then you can edit and modify these programs. So in this tutorial, we will use the Trinket link. So if you click the Trinket tutorial, you will be coached through the Trinket website, which requires, again, an email for you to log in. And once you are logged in, you can modify the existing programs. And as a good start, you can go to this tutorial and look at the different sample programs that you can modify to learn the basics of Visual Python. So an introduction to Trinket, beginning attributes, and so on. So for this tutorial, we will start by creating objects. So we will use the VPython help to guide us on how to create objects. So just choose 3D objects that you want to create here. So if you start at the overview, you can see how you can modify or create objects like cylinders, and then how to put attributes inside the cylinder or any object function. So first is you log into your Trinket account, you can use your email or any email that you are using, and then go directly to the script page, and then you type your code. So if we want to create a spherical object, then you just see or look at how to generate a sphere. So what is needed is the object's position and then the dimension or the radius or any attribute that you need to include, like size and also the color. So you can start by creating a sphere. So here we use the hash symbol to make comments. So create objects. So if you type sphere and include close and open parentheses and run, then you can see immediately the created sphere or the spherical object, which is by default positioned at 0, 0, 0, or at the origin. And the radius of this is 1. So from the sphere program or sphere function, so this is the function used to create the spherical object, you can add attributes. So POS is one attribute, meaning the position of the sphere and the radius of the sphere. You can also add colors to it. If you work with 3D objects, you can see color and opacity and how you can create colors. You can represent it as a vector 1, 0, 0. So the components of this vector will be red, green, and blue. So if you write 1, 0, 0, it means that 1 represents red. So the value range from 0 to 1. So if you write purple instead of writing 0.4, 0.2, 0.6 as components of the color vector, you can just write color dot purple. So this is a good reference in making color attributes to your object. So go back to the program. So we locate the position vec 0, 0, 0, and let's say the radius is equal to 0.2. And then you can create a color attribute. Color is equal to vec 1, 0, 0. So that's the red representation or the vector representation of color red. So running this program, you can see that you now have a red object with radius 0.2. So if you have non-zero elements of the color vector, let's say 1, 1, 1, so it means that you add red, so that's the first component, green and blue. So if you add red, green, and blue, you get the white color. So you can also just write or type the color attribute color.red, and then you can create the color red. So we have missing parentheses. Okay. So if you want to create more than one object or more than one sphere, you need to represent each object as a variable. So you can include a variable name, let's say ball1, or you can think of any name that you want, maybe sphere 1, sphere 2, and so on. And then create another object but we changed the label ball2, and now we change the position. So we put it in y-axis and change the color to, say, yellow. It's now in position 1010 and radius is 0.2. Now we change the color to yellow. First we save this and then run again. Now you have two created objects. So if you want to create another object, let's say a cylinder, so you can just write or type cylinder, and then you can include the position, axis, and radius. So axis is the orientation of the axis given in this plot. So axis is equal to the first component of the vector is the length, and then the rest is y and z components. So if you type cylinder, so without any attribute, as long as you add the close and open parentheses, then you can create this cylinder. So if we want the cylinder to be a rod connecting the two objects, you need to orient the axis such that it is aligned in the line connecting the red dot and the yellow dot. So we define this as the rod1. So you add the position vector. So position is, let's say the position will start at the origin, vec 0, 0. So you can use this. Okay. And the axis will be in the direction of ball 2. So let's see how this changes the orientation, and then we will modify the figure accordingly. And then change the radius to, let's say, 0.1, just smaller than the two objects. Now you already connected the two objects. So for rad1, you can also modify the vector. Instead of writing again the origin, you can also change this to the position of ball1 dot pos. And then the axis will just be the difference of the position of the ball1. So we write ball2 minus ball1 dot pos. So we need to include the attribute ball dot pos. Okay. And then you will have the same figure. So just to check what, verify what we already included in the attributes of rad1. If you use the function print, and then put ball or rad1 dot pause. Okay, and then run this. You can see that the position is actually at the origin, which is given here in ball 1. So the advantage of using this uh, attribute allocation is that if you change the position of the ball, let's say we put it in the negative y, -2, y equals -2, and then at x equals 2, you immediately change the position of rod 1, and then the rod's length is adjusted accordingly. So maybe we also adjust a bit the radius to 0.05. Okay. Also, if you verify the axis, rad1 axis, which is just the difference of the position of ball 2 and the position of ball 1, you can see that you get -2, 3, and 0. So that means 2, 0, which is ball 2, 0 minus 2. So you subtract component by component, you get -2, and then 1 minus -2, you get +3, and 0 minus 0, you get 0. So that's how you create uh, objects in Visual Python. So we can also use this to draw vectors. So instead of a rod, you can use another object. So choose 3D object. Let's say arrow. Normally we use this to represent a vector. Okay. So arrow will need a position attribute, axis attribute, and the shaft width, meaning the uh, aspect ratio or how thin is the arrow that you want to create. So we put the position of ball 1 to 0 again, or put it back to the origin. Okay, and then let's put ball 1 or ball 2 at 1, 1, 0. Okay, so instead of a rod, we use an arrow. So typing arrow and then include open and close parentheses. The default position or location of the arrow is at the origin, and it points in the positive x-axis. So if you want to draw arrows to represent the coordinates, so take note, ball 1 is the red ball, and we want to draw the coordinates in at the origin, then we need 3 vectors. Let's say ax. So that's the arrow representing the x coordinate. So by default, this is at 1, 0, 0, but we can still put the position at the origin. And then the axis points in the direction of positive x. So 1, 0, 0. You can also put a color attribute if you want. So let's say instead of color, we can use 1, 1, 0. So that's yellow color, red plus green. Okay. And then we create another vector or axis representing y and z. So we copy ax, and then we just modify the variable ay, same position. So it will start at the origin, but the non-zero component should be y. We have ay, and then change this color to 1 and 1, 0, and 1. So that's red plus blue, which is magenta. Okay. And lastly, for the z component, we change the variable to a z, or you can use any variable name that you want and change the axis to 0, 0, 1. And then change the color to 0, 1, 1. So 0, 1, 1 means green plus blue, which is cyan. So the yellow ball is located at 1, 1, 1. And the back axis is given as yellow X, magenta Y, and cyan is Z axis. Okay. So you can also create a coordinate plane. So now the coordinate plane would be the XZ plane. So going back to the GlowScript help site, choose a 3D object. So the one we use to represent a plane is a box. Box, and then position given vector 0, 0. So this is the center of the box, and then you can include length, width, and height. Or instead of using length, width, height, you can just add a position or size attribute, length, height, width with the vector. So go to script and then create the plane, and then include the box. So if you don't put any attribute, it will just create the default box figure at the center. Maybe we need to save this again. And then play. So now we created a box centered at the origin. So to make this a plane, position vector is at the origin. And then size, you include length, height, and width in vector form. So let's say length is 10, height is 0.5 and the width is also 10. Let's include a color attribute, green. So 0, 1, 0. So now we have this plane, but because the objects are too small, they were embedded inside the plane. So you can see that the radius is 0.2. So we can adjust the height of the plane. It should be smaller than the radius. Let's say 0.05. So now you can see the coordinates X, Y, and Z. So you can also extend the length of each of these axes if we add a scale equal to 5. So you just multiply the axis using that scale. So scale times the vector so that it will be extended in the coordinates. So you can see that it has been scaled accordingly, but you can see that the aspect ratio is um, not comparable to the size of the object. So what we can do is to adjust the shaft width let's say to 0.1. Let's try and value 0.1. Maybe it's too thin. Let's make this 0.5 or zero point 0.2. Okay, better. And now we copy this attribute for the two other coordinates. So we now have the coordinate axis, and then included here is the location of the ball at 111. So you can also change this to other values, let's say -2. So -2 in Y, so we can see that the object now is at the bottom of the plane. Now if we make this -2, so it will be located at the back of Z-axis or along the negative Z. Okay, so if you want to add other objects, let's say another object ball2, you just change the variable to another variable, let's say ball3, and then we change the location. So we place this at -1, and then change to the color to say purple. Okay, again, we save this and then run the script again. Okay, so now we have two vectors or we have two objects located above the plane. So if you want to draw the position vectors, meaning the location of these two vectors, you can draw arrows. So let's say we have vectors A2 and A1. So A2 is the vector representing the position vector for ball 2. So you just uh, represent this as arrow and then include the position. So the position of this vector should be the position of ball 2. Ball 2 dot pos. And then the axis will be equal to the location of ball 1, which is the origin, as reference, and then you have ball 2 as the location. So ball 2 dot pos minus ball 1 dot pos. So we use the same attribute for the shaft width. Say 0.2. Okay. Now we need to put the axis starting from the origin. So this should be ball 1. The position will be at ball 1. And here you can see the vector, the position vector representing the location of ball 2 to be from the origin up to the position ball 2. So we do the same with ball 3. So we just copy this. Now, we define this as vector A3. So the position shall be also at the origin. So the ball 1 dot pos. And then the axis should be ball 3 position minus ball 1's position. So now we can see these two position vectors connecting the origin and the position of the two components, or the position of the two vectors, or location of the two vectors. Now, if you want to get the difference of these two vectors, let's make that A3. So you just represent that as arrow. So the position is, let's say we want to solve for R3 minus R2, or the position of ball 3 minus position of ball R2. So the position should be ball 2, and then the axis is ball 3 dot pos minus ball 2 dot pos. And let's change the shaft width to 0.1. Maybe we change this to 0.1 para mas manipis. And then copy the shaft width attribute. And then we assign a color. Let's say point 9, 1, and 0. Okay. So now you can see uh, the difference. So the vector difference of R2 and R3 is given by the yellow vector. So the yellow vector points from ball 2 to ball 3. So if you change the position of the balls, so let's say we change this to X, Y plane. Okay. So it follows that the vectors A2 and A3 together with A3 or together with A4 will change. Let's see kung nabago natin yung position vector. Okay, so this should be A4. So if you change this to negative Y, so now the object ball 2 is now located at the bottom. Now you can see that the position vector changes accordingly. Both the vector difference and the position vector A2. So let's put it back to 2 and then add another Z value 1, 2, 5. Positive 1, positive 2, and positive 5. So once you set up the coordinate system, you can make other examples on how to compute visually the values for the vector difference. So if you want to solve for the components, just print the axis value. So let's say we want the vector difference. Quotation. So vector difference A2 minus or A3 minus A4, comma, and then that's the value of A4 dot axis. So it will output the value of this vector difference. So running this, you can see that you have -2, -1, and -4. Maybe we put equal sign. Okay. So if you only want the X component, you just include dot X. So that will reflect -2. So just to check, we go put this back to the vector notation. Ball 3 is -1, 1, 1. So you subtract that to ball 2 position, 1, 2, 5. So -1 minus 1 is 2. 1 minus 2 is -1. And then 1 minus 5, you get -4. So as you change the values, you can also see the changes on the values here. Okay. So you can also include text. So in the text, you can include the vector difference. So for example, we want to input this quantity, or if you want to include a title, my text is equal to text, and then inside this quantity, you include the text. Open close quotation. Let's say 3D visualization. Okay, so if you want to include the position, you just include position, and then we represent this as a vector, so it should be at the negative y. So x is, we start at -2, and then let's say -5, and then 0 in z. Okay, so now you can see the title is also embedded in the 3D model. So in the text, you can also align it to the center. So if you include this attribute instead of putting position vector, so align is equal to open close quotation center. So it will be exactly at the center of the image. So if you use the position, then you can assign manually the location or position of the text. So position vec, let's center it more. Let's say -5, comma -5, and then 0. Okay. So this is a brief demonstration on how to use Visual Python using the web to model 3D objects.